In this chapter, we're going to look at the normal distribution. But let's go back and review a few things. First off, you remember we had this formula before to find the z-score, or we also referred to it as a standard value or a standardizing of value. So in this case, what we're going to look at here is we have three values. We have our x, we have our mu, our mean, and we have our standard deviation of 5. Well, if I want to find the z-score here, I'm just going to plug those numbers in. So 45 minus 43 divided by 5. Put that in the calculator, and you're going to get a decimal. And we always go 2 decimal places with z-score, no matter what. So what this number is saying is that our value, our 45, is 0.4 deviations above the mean. Above because we're talking about a positive number here. This talks about the number of deviations above the mean that it is. This puts everything on a standard level. That way we can evaluate things that we normally couldn't evaluate before. For example, what if a person took a test and the mean score was 22.5 and they scored a 19? Well, if another class had a different mean, a 19 would be a different score relative to the mean. Well, I'm just going to plug it in. Once I plug in the values, put this in my calculator, and this is going to give me negative 1.6 repeating, but remember, 2 decimal places for z-score. So what we have here is we're considerably below the mean. In a different scenario, where let's say the mean was smaller, maybe 20, a 19 would have a better value comparative to the mean. So this allows us to take values that aren't on the same scale and compare them. It takes the label out of the mix. Let's look at our next slide here. So now we're taking this same formula and we're mixing it around a little bit. What we're talking about here is, what if you have the z-score, but you're missing this value, the x value? And the normal distribution, we'll actually be able to find that score using some certain things. So in this case, I have my mu, I have my deviation, my sigma, and I have my z-score. Just like the last one, this is just a plug-in. You do your multiplication first, so you get 4.8, add the 20. So a score that is 1.2 deviations above the mean is 24.8, assuming the mean is 20 with a deviation of 4. In the second example, we're talking about a score that is about half a deviation below, not quite half a deviation. We'll do the same thing. Now I should expect a value smaller than 16.1 because I have a negative z-score. Always keep in mind, when you start looking at this, evaluate ahead of time. Should my z be bigger or smaller? When I put this in, I round off to 2 decimal places. You can go 3 if you want. I end up with this. It's a negative number. And I end up with an x value, a score, or whatever, of 15.67, which is about almost half a deviation below the mean of 16.1.